So there's a God. Then you have to say, but sorry, where did God come from? It's not a question I hear often answered.
In order to recognize that an explanation is the best, you don't have to have an explanation of the explanation. In order to recognize that an explanation is the best, you don't have to be able to explain the explanation. Folks, this is an elementary point in the philosophy of science. Suppose astronauts were to find on the backside of the moon a pile of machinery there that had not been left by American or Russian cosmonauts. What would be the best explanation for that machinery? Well, clearly it would be some sort of extraterrestrial intelligence that had left the machinery there. And you don't have to have an explanation of who these extraterrestrials were or came from or how they got there or anything of that sort in order to recognize that the best explanation of this machinery is intelligent design. In order to recognize an explanation as the best, you don't have to have an explanation of the explanation. In fact, when you think about it, requiring that would immediately lead to an infinite regress of explanations. You would need an explanation of the explanation, but in order to recognize that as best, you need an explanation of the explanation of the explanation, and then an explanation of the explanation of the explanation of the explanation. And so that nothing could ever be explained.
One of the outdated philosophical cliches, in my opinion, is that, well, who created God? We hear that all the time, and they think it's a baseball bat against the theists. But it's made of sponge. And let me tell you why. If we say, what caused the cause that caused the universe, then let's continue. What caused the cause that caused the cause that caused the universe? Let's continue. Then what caused the cause that caused the cause that caused the cause that caused the universe? Let's carry on. Then what caused the cause that caused the cause that caused the cause that caused?
And that goes on and on and on backwards. But at one point, I have to have an uncaused cause, or there would be nothing in existence today. Think of a string of dominoes. You have a domino that knocks over a domino that knocks over a domino. I have to have a first domino, or that string of falling could never start.
So in essence, to claim who created God or what caused the cause of the universe is equivalent of saying that we don't have a universe, that we don't have a universe, that we don't have a universe.
Remember the premises of the argument I gave. Everything that begins to exist has a cause. Something cannot come into being out of nothing. But if something is eternal and timeless, then it doesn't fall under that first premise. It doesn't need a cause. And the concept of God is the concept of an eternal, self-existent, necessary being, and therefore the answer is simply that God is uncaused. He is self-existent.
Dear Dr. Craig, one of the objections which has been raised is the first law of thermodynamics, the rule that matter and energy can only be rearranged, or in other words, that matter is neither being created nor destroyed.
Yeah. What's funny about this objection is that this is not an objection to the existence of God. This would be an objection to the Big Bang theory of the origin of the universe. It would show that the Big Bang theory of the origin of the universe is false, because according to that theory, all matter and energy, even space and time themselves, came into being at the moment of the Big Bang, and are therefore not eternal. They haven't always been there in the past. So if these fellows were right, all contemporary cosmologists who believe in the Big Bang theory of the origin of the universe would be contradicting the laws of thermodynamics, and that's hardly the case. Why? Well, because the laws of thermodynamics, in particular the law of the conservation of matter and energy, only applies once the universe comes into being. It applies at every moment, at every time, and every point in the universe. But it doesn't apply to the origin of the universe itself. And that's why cosmologists don't consider that the law of conservation of energy and mass is violated by the Big Bang theory of the origin of the universe. In fact, the atheist fellow mentioned the laws of thermodynamics. He might have wanted to talk about the second law of thermodynamics, which says that in a closed system, things tend toward increasing disorder. Now, the universe on the atheistic view is just a gigantic closed system because it is everything there is and there's nothing outside it. And what that implies is that given sufficient time, everything in the universe would grind down to a state of maximum disorder. So if the universe has existed for infinite time from eternity past, why is it that we don't find ourselves in this sort of thermodynamically disordered state? I think that the best answer to that is that the universe has not existed forever. It began a finite time ago in a low entropy condition, and the thermodynamic clock has been running ever since then. So the evidence of thermodynamics itself suggests that the universe and matter and energy are not infinite or eternal in the past, but had an absolute beginning.
To remind ourselves of the argument again, we have premise 1, whatever begins to exist has a cause. Premise 2, the universe began to exist. And from that we draw the conclusion that the universe had a cause. The universe had a cause. The universe had a cause.
So we ask another question, what is the nature of this cause? And the nature of this cause, upon conceptual analysis, which means critical thinking about this cause, we come to some startling conclusions. This cause must be one. The reason for this is because if we use the philosophical principle Occam's razor, which posits that we do not multiply entities beyond necessity, then we conclude it must be one. This cause must be uncaused, as we have already discussed the absurdity of an infinite regress of events. Similarly with causes. This cause must be immaterial because it created the sum of all matter, which is the universe itself. Significantly, brothers, sisters and friends, this cause must be personal. The reason I'm saying this is how else can an eternal cause bring into an existence a finite effect, the universe that had a beginning in time? It must have chosen the universe to come into existence, and choice indicates a will, and a will indicates a personality. So, we have concluded the traditional view on God, that a transcendental, immaterial, uncaused, eternal being exists. Being exists. Being exists. Being exists.
Some strange results have come up in about the last 20-30 years, particularly in astronomy and also in quantum physics, which suggests that the universe actually may have a purpose, and some physicists are now suggesting it does have a purpose. And this has come out of some findings about some of the fundamental numbers in atomic physics.
During the past 40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
These are numbers like the mass, the weight of an electron, the weight of a quark, the strength of gravity, the strength of the electromagnetic field. About 20 numbers that describe those and other parameters, features of our world, but nobody knows why it is that those numbers have the particular values that they do. Now, you could easily say, yeah, who really cares? You change the mass of the electron by a little bit more, a little bit less. Does it really matter? And the answer is it does. See, it turns out that if you imagine that we had 20 dials right here, and we could fiddle with those 20 numbers at will, even a small change to the values of the known values of those numbers would cause the world as we know it to disappear.
Because it turns out, and this is a very surprising, unexpected discovery, that the laws of physics, the basic given fabric of the world, had to be very specific, very finely tuned, as we sometimes say, for the possibility of carbon-based life appearing at all.
For example, the strengths of the other forces are all important, the masses of the various subatomic particles. Now, this is one of a long list of properties in underlying physics that seem to be prerequisites for a universe with life. If all of these things were even a little bit different, then life, certainly life as we know it, could not exist.
It's a very surprising conclusion, but it's true, and all scientists would acknowledge that's the case.
Bernard Carr is a cosmologist and studies how the laws of physics operate in the universe. He says that the laws of nature are so finely tuned to enable complex life to exist that it is extremely unlikely that this could have happened by chance. Such fine-tuning, Carr believes, at least raises the possibility of a tuner.
This is a diagram, it's called the pyramid of complexity, and what we've got here, we've got the different levels of structure in the universe. And at the bottom we've got the things like quarks that make up the atoms, and the atoms build up to make molecules, the molecules build up to make living cells, the cells make organisms, and eventually we end up with brains and consciousness. It's rather hard to estimate what the probability is, but it was clearly very, very unlikely that those fine-tunings which allowed this pyramid of complexity to arise would be there.
A very simple and central example is the question of where does carbon come from? The very early universe doesn't make any carbon. It's very simple, it only makes simple things. Hydrogen and helium, and they're pretty boring in terms of chemistry. Now, where does carbon come from? There's only one place in the whole universe where carbon is made, and it's in the interior nuclear furnaces of the stars. We are people of stardust, made of the ashes of dead stars. And it turns out that the process by which carbon is made inside the stars is an extraordinarily delicate process. In fact, it looked at first sight as though it couldn't happen at all. It's only possible because there's a very large enhancement effect called a resonance in the tray, which makes it go much quicker than we might have expected. And that resonance is there because the laws of nuclear physics take a very specific form. If they were a little bit different, either there would be no resonance or it would be in the wrong place at the wrong energy. That's a very striking example of how finely tuned the universe has to be for us to be inhabitants of it.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything is bad. And a physicist could say, maybe those are just luck. On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120, 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion, 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 trillion. Otherwise the universe would be so drastically different that it would be impossible for us to evolve. That the cosmological constant arrived at such a tiny value by chance seemed to be out of the question.
Ils sont nombreux à dire que finalement, quand on regarde l'univers, surtout à l'origine, eh bien, on constate qu'il ne peut pas être né par hasard, et que le hasard n'a aucun rôle, et que plus on remonte loin dans le temps, donc plus on remonte vers le Big Bang, plus on trouve un univers qui est ordonné, réglé, ajusté.
For example, if we go back to say 1 second after the Big Bang, at that point the expansion rate and the mass density have to have been adjusted to each other just right, so that the universe is just at this critical point. If the universe at that point were expanding just 1 part in the 15th decimal place faster, the universe would have flown apart without galaxies ever having had a chance to form. On the other hand, if the expansion rate were just a little slower than what we think by change of 1 in the 15th decimal place, then the universe would in fact have expanded to a maximum size and collapsed. We would never have even reached the time in the universe at which we're living.
Alors, ajuster comment? Eh bien, il existe ce qu'on appelle des paramètres cosmologiques. Ce sont des grandes constantes, la constante de la vitesse de la lumière, par exemple, qui fait 300 000 km à la seconde, 7 fois donc le tour de la Terre en 1 seconde. Il y a la constante de gravitation. Ce sont des chiffres, des données chiffrées, avec un zéro, une virgule, et puis parfois des dizaines de décimales derrière la virgule. Eh bien, si on changeait simplement une seule de ces décimales sur une seule de ces 20 constantes, l'univers ne pourrait pas apparaître. Eh bien, ça signifie que le hasard n'a aucun rôle à jouer à l'origine de l'univers.
How did this come about, this rather terrific luck?
Of course, one of the first explanations that comes to mind is that there was a tuner or a creator, or if you like, God. And obviously for people of a theological disposition, the idea that the fine-tuning is evidence of God, of course, is wonderful.